It's going to take me just a little bit to get there. We're going to go off of screen sharing for a moment. And let me see if I can find, because I know I had it open, but I cannot see this, so I'm going to go here to okay. Oh, here's Ashford. Let me let Ashford in first. Ashford is here. All right. Let's see. There's just too many moving parts here, and the slide I want to show is not showing up here. So let me scoot this over here a bit and go up here and find, okay, here we are. What I'm doing, I'm getting to our page in Blackboard. So I'm going to start screen sharing there if I can. I think what I have to do is get out of this screen share and start a new one. Okay, yeah, there it is. Okay, now, can you see my opening page of Math 112 Pre-Calculus Algebra? Right? Okay. Go to weekly assignments, and unfortunately I'm going to have to, y'all can't see this, but y'all are, the list of you is in the way here, so I have to move you out of the way. Okay, I'm going to come over to the right hand side and do the arrow down by weekly assignments. Okay, now go down to week 1, and every week I say go back to week 1 and see this, so that's where I put it, in week 1. Scroll down until you see instructional materials, lessons, PowerPoints, videos, handouts, and so forth. Click on that. Okay, and this time you have to go down, okay, right here. At the very bottom where it says ETC, Other Materials, that's where I put the Cengage class key for this course. Is that what you need? It's also the WebAssign. It's the same. I should later. Yeah, that's WebAssign as well as Cengage. That gets you the book, it gets you WebAssign, it gets you everything. Is that what you need? Okay, so that's where it is under week 1. And every week I say see Cengage, WebAssign, class key located in week 1. So that's where it is. All right. Okay, Shirley. Any other questions?
Mr. Fowler.
Yes.
Hey, I have a conference call that I need to be on. So look for me. I'm gonna come back.
Okay, I always am looking for everybody who gets bumped out or has to leave or whatever. So yeah, I'll be watching for you. Be sure you use this code. Okay. Yeah. Okay, say that one more time. Yeah, I caught you when you were in the waiting room. You got a what? Okay. All righty. Okay. All right. Any other questions, issues, concerns before we're already recording, but I just wanted to get anything like this out of the way before we get into the math. Anything? Okay, my phone's ringing. I don't think it's anybody I know, so I'm going to let it ring. Okay. So, let's go back to, goodness, it just keeps ringing and ringing. Okay. 1.7, and we'll open from current slide. Goodness gracious. Well, it can ring to his heart's content. Okay. Now I got to move y'all back. Rosa, you're in the way again. Okay, here we go. I got you back to the side. Goodness, it just keeps ringing. It's called twice. It says, I don't see meeting ID to log in. Let me see who that is. Must be one of you. Yes, this is Charles Fowler. Had you called me? Yeah, yes. Well, a bunch of other people were here. They saw it. I don't know. Okay, okay. Um, Let me see if I can find it easily here. Let me go back. Okay.
I think it's 302056.
302. Say again.
056.
Okay, I heard 302 and then something 56.
056.
Okay, no, 302056. Is that correct?
Yes.
Yeah. Somebody else is telling me that. Okay, so that's why I'm repeating. And when they start talking, it cuts you off. When you start talking, it cuts them off. Okay. All right. So does that do you for it? You need the what? Okay. What? Let me see if I can find the passcode. Okay.
That was the passcode.
Oh, that was the passcode. What's the?
I'm sorry.
Okay. Yeah, the meeting ID is
985
985
1736.
1736. Is that what you said?
Yes.
Okay.
7753.
7753.
And the passcode is 302056.
And yeah, you got the passcode already, right? Okay, great. Thanks. Bye-bye. Okay. What a start to the day. Okay. Now let's go back to 1.7. Okay. And D is now coming in. Okay. So let me get the last two people who got here. I know D was one. And someone came in just before D. And I admitted them, but Shamari. Okay, that's right. Okay. All right. So, and you're listed as PC, right? Shamari? Yeah. Okay.
Yes.
Okay. So let's see. Make sure I have everybody here. I should have 16 students here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I have 18 that have been here, but I think a couple of people did have to bump out for a bit, and hopefully they'll be back. Okay. And who is this? Yes, I got you when you were coming in. Let me just make sure I marked you in the right place. Yes, I got you. After the initial rush of people coming in, then when people do get in the waiting room, I go on and mark you on the roll, but it's always good to ask. So thanks for asking. All right. Okay. Any other issues, concerns, problems, and so forth? Okay. If not, we're in. By the way, happy October, everybody. 1st of October, which means, of course, you now turning in your research paper will only get you 2 bonus points. So please get those papers in this month so you can get your 2 bonus points. In November, it drops to only 1, and in December, you don't get any bonus. You just turn it in, you get your score. If you're after the last day of class, you start losing points. So please remember your research papers. All right, we're in Chapter 1, Functions in the Graph. We're in Section 1.7 transformations of functions, and on page 69, reflecting graphs. But before we do that, let me make sure. I know last time some people could not read the graphics on the test, and that had happened in another class or two. The computer they sent me from the campus had, I guess, the most current version of Word on it, and that's what I used to do the test. And by using, and it's an awkward package. I really dislike most Microsoft products, and this was one of the worst. In order for me to do the equation mode, which is so incredibly easy in WordPerfect, which is what I sort of grew up on, and it was they've had it out there for years, decades, a wonderful equation editor, and Word can never get it right. So they went to one that I have to use my finger and do the equations that it doesn't recognize and stuff, and it's such a pain in the neck to do. But I finally get it right, and then I found out y'all can't read it because it's the newer version and it won't be read by older versions, and that aggravates the mud out of me for Microsoft. They always do this. They upgrade things and make it so it's incompatible with previous versions, so you have to buy. That's how they make all their millions, and billions. I don't know how many dollars they make, but anyway, they make them by forcing people to upgrade by minor little, sometimes worse changes than what were there before. So sorry about that, but I did put it out there as a PDF file. I put that out Tuesday, but Tuesday afternoon my computer just started slowing down like crazy. We did a lab. Most of the students were in the lab before mine would even open the lab, and it was just, I would be showing them how to do it. They'd say, yeah, we're in, but I couldn't get in because the computer, I don't know what was wrong with it. And then after class, I started trying to print things. Well, for instance, that thing, the computer and printer were not communicating well, and I tried everything I could think of to do. Finally had to shut down everything, start back afresh, and I was finally able to print your test. It says quiz 1, but it's test 1. I was able to print it so I could take it down and take a picture of it with Adobe Scan, and then come back up and email it to myself and come back up and process it so I could get it into an Adobe file, so a PDF file, so you could see it. So I hope all of you got to see the first test. It says first quiz, but test 1, one page, and then I think I sent with it also, with the first version, a Adobe scan of the graph paper, but that graph paper was in light blue ink, and the Adobe scan did not take a very good picture, but I tried several times. It's the best I could do. So I hope you are able to get enough of a piece of graph paper to do the graphs. Did everyone see that? Do you realize it's there? And if my memory's right, whoever set up this silly template did not put a way for us to send the test under test 1, so I had to send it, and I planned to send it anyway, through Blackboard Message. So that's where you'll find both the first version of the test, the graph paper, those are in one file, and then the PDF for the test is in the second file, or in the second message I sent. The PDF for the graph papers in the first one. So everybody able to access those? Any problems there?
I can't see it.
You can't see what?
When I click on test 1, nothing pops up.
Okay, now is that test 1 under weekly activities, or is that test 1 under on the Blackboard messages?
Let me look up on Blackboard.
Yeah, go to Blackboard messages, because in week 1, where I was going to put the test, they they have the situation, they have the page there, but they don't have any way for me to put something on the page. There's supposed to be a little plus sign there. I click on that and then I can put something in. Whoever set up the template didn't make it so I could send you anything. I think you can send me stuff if you want to through that, but I can't send you anything. It was a human error, I think, but it's also Blackboard. It's just an awkward package. And here comes Ivan. Let me get Ivan in here. And I don't know what I did with my pen. It must be, yeah, there it is. Get Ivan here. All right, let me just make sure nobody else is in the waiting room. Nope, looks like I got everybody. It says I have 17 students here. I bet you I have 19 on roll. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Yeah, because Terrell and Jakaria had to check back out, and they're coming back, they hope. All right. Everybody okay then? All right. Let's finally get around to precalculus algebra. Okay, though we've been talking some about it. We're on, as I said before, and for Ivan and others who came in since I said this earlier, we're in Chapter 1, Functions in the Graph, 1.7 Section, Transformations of Functions, on page 69, and we're starting example 2. The graph of f of x is equal to x to the fourth. Now, I don't know if you remember the parent functions we had. The quadratic function, the squaring function, looked a lot like this. There was one difference. The squaring function came down a little more gently, coming down here, and then was more rounded here and going back up more gently. Okay? That's one way to express it. When you have any even power, like x to the fourth, that comes down more sharply here, but then near 0, it flattens out a lot, but then past 0, it goes up more rapidly. If you had x to the 6, it would come down even sharper than this does, and it would flatten out a little bit longer here, and then shoot up even sharper there. X to the 8th, it just continues that pattern of being sharper outside plus or minus 1 and being flatter in between plus and minus 1. There's minus 1, there's plus 1. So here's the graph of the function x to the fourth. Okay, that's the setup. Now, what we're asked to do, if I could get the slide to move, is each of these graphs is a transformation of the graph of f that we saw before. Now, this time before, they've written the equation and you draw the new graph. This time they're going the other way and saying, you write here is the graph, you write the equation. So what's the first thing you see happening to this graph to make, say, this graph, g of x? Anybody? What's the difference in f of x here and g of x there?
Is it reflected?
Exactly. The first thing you got is a reflection. Now let me go back to the f of x. Well, I went the wrong way. Okay? And get my pen. And if you just reflected, it would have been, and this is going to be a terrible rendition of a drawing here, something like this. Just the reflection would have been like this, flattening out here and then going down like that. That would have been a reflection. Okay? And what would that have been represented by? This thing I just drew here. I'm going to make up a new letter for it. I think they use G and H on the other one. I, J, how about K? Let's do K of x. This one that I just drove here would be minus x to the fourth. That indicates a reflection across the x-axis. Okay, what's the next difference between, say, this one, k of x, and this one here? Yes, just say up to, just don't say yours. Okay, so got it. So up to, so what would that be? Then this y, which is equal to g of x here, would be my k of x I did before plus 2, because you went up to. You took the y value up to. But the k of x, remember, was minus x to the fourth, and then you add 2 to it. So this is the reflection, flipping it over, and this is the vertical shift upward. How about this one? What would you say h of x is? Starts with the same thing, doesn't it? Starts with a reflection, so that would be a minus f of x, but not just f of x. What else have you done here?
Move to the right.
Okay, and how do we express that? Since that's horizontal, what axis is the horizontal axis? X-axis. So the x is moved to the right 3. And remember, x's are always backwards. That makes it a minus 3. You're not subtracting from the function. You're subtracting, well, not subtracting, well, you are. Subtracting from the x, but that moves it to the right 3. So that would mean you're minus x minus 3 to the fourth power. Do you see how that works? This one, after you reflect, a vertical translation, up to. This one, after the reflection, that's the minus sign, you move to the right 3, which means you subtract 3 from the x to get you over 3 to the right, but it's still the same shape. Okay? And these, by the way, are called rigid transformation because that shape of the function is exactly the same shape of this one. It's up, flipped over, and then moved some. Okay? Does that make sense? Any questions about it? Let's see how the book did it. The first one, they said the graph of G is a reflection in the x-axis, got it, followed by an upward shift 2 units of the graph of f of x equal x to the fourth. So what would that make it? So the equation for G would be minus x to the fourth, that's the reflection that you do first, and then adding 2 shifts it up 2 units. Okay? Exactly like we got. The B one, the graph of H is a horizontal shift 3 units to the right, and then they said followed by a reflection in the x-axis. It doesn't matter on this one whether I would say reflect first and then shift. They say shift first and then reflect. In this case, it doesn't matter, okay, because both of those. Up here, if you had shifted first and moved it up 2, it wouldn't have then been a reflection in the x-axis. It would have been a reflection in that line y is equal to 2. And that then just makes it a little more awkward to talk about. So if you reflect first and then shift, you have no ambiguity. So I like to say that the horizontal shift 3 units to the right follows the reflection, not followed by the reflection. Okay? I think they were, it doesn't matter, but in this problem, it would have mattered in this one. So why not keep it consistent? Why not do the reflection first, then follow that with the horizontal shift? That worked perfectly well. So what do we have? Here's a reflection, and there's a shift. Okay? Now, I think I see why they said that, because usually you do what's in parentheses first. Please excuse my dear Aunt Sally. And you would have shifted this first and then reflected. But just to keep it the same order we did before, and to remove the ambiguity, I like it better the way I said. Both of them are correct. This one, you have to negate first, that's the reflection first, then add to, okay, in the order you read it. Okay, any questions on that? All right, there is a checkpoint at the bottom of that problem, as there is every example. Please do the checkpoints. A great thing to do while it's fresh on your mind as soon as you can after class. If you can't get that, remember you can go to audio video solutions are available for the checkpoints at larsonprecalculus.com. But before you even go there, you could check in the back of the book where the answers for the other things are. The checkpoints are there too. The exercises, the checkpoints are there too. And now we're moving to okay, wait a minute. Here comes Tamia. Let me get her here. I almost missed her because I was looking at the book. Tamia is here. Got it. Okay. Okay. Now, this is some verbiage that I don't see specifically in the book. It's actually pretty much there as a example 3, but they're not calling it example 3 here. But anyway, I think they will. When sketching graphs of functions involving square roots, remember you must restrict the domain to exclude negative numbers inside the radical. Okay? So if you have certainly the square root of x, let's start with that one. What if you just had, where is my pen now? Wrong end of the pen. That's why. Okay, here we go. Well, if you just had the square root of x, obviously anything under a square root or any even root has got to be positive. So this says x has to be, or non-negative, greater than, get out of there, greater than or equal to 0. Putting a minus sign in front doesn't change what's under here. The x still has to be greater than or equal to 0. But if you put the minus sign in there, then minus an x has to be positive. Remember, negative x cannot equal 0, so therefore, well, this is going to be hard to say. I'm sorry, used the wrong symbol. That's why it's hard to say. Wait a minute. I found out the other day, I think I showed you in this class, I can erase now. Okay. Okay. All right. Negative x has to be greater than or equal to 0 because that's what's under the radical sign here. When you multiply or divide by -1, you change the direction of that directional inequality. It has to be less than. These should be or equal to 0. And that's why this changed here. Here, the minus sign up front doesn't change the domain. It'll change the range for sure. It's just like this one would. But the domain is this. X plus 2 has to be, whatever's under that radical has to be greater than or equal to 0. You know that. Anything under a radical, an even root radical, even index radical, has to be positive, non-negative. So it's greater than or equal to 0. Then you subtract 2 from both sides. Adding or subtracting on either side doesn't change the sign. Only multiplying or dividing by negative numbers changes the direction of the inequality. So this becomes x is greater than or equal to -2. And that's what they got here. So that's what you have to keep in mind with domains. Now ranges, they change too. The range of this one, sorry, if I can find my pen, there it is, okay. Range of this one, all y has to be greater than or equal to 0. This one, y has to be less than or equal to 0 because you negated that principal square root. This one, the x has to be less than or equal to 0, but the y is still greater than or equal to 0 because this is principal square root. This one, the x is shifted 2 to the left because it's a plus 2, remember, to the left, but then the y has to be less than or equal to 0. So not only your domain is changing, the thing outside the radical changes the range, inside the radical changes the domain. Okay, does that sort of make sense? Let's see if they, whoa, and no they don't. They go right into, so let's do example 3. They were talking about these and they say compare the graph of each function with f of x equals the square root of x. Now I've sort of been talking through it. Let's go to the whiteboard and actually do it. Okay, now that I'm on the whiteboard, I have to do some shifting around myself, and you can't see it, but there's a toolbar that gets in my way of seeing the whiteboard and writing on the whiteboard. Well, actually I could write on it, but I couldn't see what I was writing. Okay, and then I move the whiteboard as far to the left and as far up as I can, so I have maximum white space to work with. Okay, so it says compare the graph. This is example 3 on page 70. Compare the graph of each function with the graph of f of x is equal to the square root of x, the one that I said let's start with. Okay, now let's draw that one first. I don't draw vertical lines or straight lines very well. Okay, or horizontal lines or straight lines very well. So let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Let's go negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, let's go up 1, 2, 3, 4, 5, 6, 7. And let's go down negative 1, 2, 3, 4, 5, 6, 7, 8. I don't draw spacing too well either. So let's first graph f of x equal square root of x, wherever there it is. Okay, f of x equals square root of x. When x equals 0, the square root of 0 is 0, and f of x is y, so that's going to be the origin, 0, 0. Okay, when x is equal to 1, the square root of 1 is 1, that's y, f of 1 is 1, that's right here. Okay, all right. I'm going to not do 2 or 3, I'm going to go straight to 4. When x is equal to 4, the square root of 4 is 2. So x equal 4, y is equal to 2. If I can find the pen, there it is. 1, 2, 3, 4, and go up 2. Okay, about there. Yuck! This thing drives me nuts. Okay, next one, let's go to 9. When x equals 9, square root of 9 is 3. Y is 3. That's 4, 5, 6, 7, 8, 9, and go up to 3, somewhere right about there. Okay, and I don't think I made it as far as 16. There's 10, 11, 12, 13, 14. No. So the graph of this is half of a sleeping parabola. It comes up like this and heads through these points here and keeps on going. If I got to 16, it would be at plus 4. So there's your f of x. Now the a part, I need a new color. And let me see if I can get my, there we go. Okay, I realize y'all can't see these. I have a lavender, a red, a pink, a brown, a yellow, an orange, a lighter brown, a light green, a bright green, and a dark green, a medium blue, a light blue, and a dark blue. Give me a color. Pick one of those colors. Anybody.
Dark blue.
Dark blue. Okay. So we're going to have G. This is the A part. G is going to be dark blue. I'm also going to erase that little mark that somehow made its way in there. Okay. All right. So here is G in dark blue here. G of x is equal to that one we were talking about, negative x, the square root of x. What is G doing to F? What's the negative sign in front do? Anybody?
So,
Okay, somebody tried to say something. I think it was Tommy, but it didn't come through here. Say again? Reflect. Okay, I heard the fleck part. Okay, reflect across the x-axis. In other words, negating every one of your y's. This is the y value, right? Negate them. Negative of 0 is 0. Negative of plus 1 is minus 1. Negative of plus 2 is minus 2. The negative of plus 3 is minus 3. Okay, so here's what that one looks like. Woo, if I could draw, that would be helpful. And it keeps on going. It basically completes that parabola that's sleeping on the side. Okay, so there was our G of x. All right, I need a different color. Someone give me a different color. Still got lavender, red, pink, dark brown, yellow, orange, lighter brown, light green. Oops, wrong one.
Lavender.
Lavender. Okay, here comes the lavender. Okay, that's going to be our H. H, can you read it well enough? H of x is equal to the square root of minus x. Now remember, this negated our domain, so the domain is now less than or equal to. So what do? Same value for y, but with the opposite x. So the opposite of x equal, where are you, pen? There we are. Of the negative x equals 0 is x equals 0. Get out of there. X equals 0. That's right there, same place. The negative of x equal plus 1 will be minus 1, but the y will be the same. So it'll be right here. Okay? The negative of x equal plus 4 will be x equal minus 4, and the 2 will be the same. It's reflected across the y-axis. Okay? And the negative of plus 9 here will be minus 9. Negative 5, 6, 7, 8, 9, and that will be up here at positive 3, if I could find it. Okay, that's going to be right in the middle of my x here. Okay, so what this one's doing, it's flipped it across the y-axis. Whoops, going up too fast here. Okay, and it keeps on climbing. Does everybody see that? You negated the x, so you flipped across the y. You negate the y, you flip across the x-axis. Okay, reflection. Okay, I need one more color for my K. What color you want? We still got red. Say again, green. You want a pale green, a bright green, or a dark green? Say again.
green.
Which green? Pale green?
Red.
Okay, I can't hear you.
Red.
Red. Oh, okay, we'll do red. Okay, sorry, my hearing is so terrible. Okay, we're going to do red if I think I got it. Okay, so this one is going to be my K of x. This is the C part. K of x is equal to minus, whoa, here comes Terrell. Let me get him back in. He's already on the books. So Terrell's back. And Terrell, if you can hear me yet, we're on page 70, example 3. Okay, right in the middle of doing the C part. The k of x is equal to minus the square root of x plus 2. Remember, we did that earlier, talked about the domain. So, in this case, we're going to, I like to think of reflecting this f, which if I could find my, oh, there's your f, reflect that across the x-axis so it looks like the blue G down here, but then what do you do here? X plus 2. We did it before. That's a shift of 2 places to the left. Remember, everything dealing with x is backwards. Since it's added to x, that means you shift left 2 on the horizontal axis and this, and you negate your y. So you're doing both of those at once. So 0 shifts to 0. Okay, goodness gracious, it drives me nuts here. The 0 shifts left to minus 2, and the reflection of the y is equal to 0 stays y is equal to 0. And then this one, this 1 shifts left to 2 places to minus 1, shifts, reflects downward to minus 1. This 4 here shifts 2 places to the left and down 2 rather than up 2. This drives me nuts. I try to draw a point there and it just takes me completely out of doing it. Okay. This 9 over here, I think that's 9, shifts 2 to 7 and it shifts reflects down to 3. So here is your graph here. Again, that parabola going like this and like this, and it actually looks like it's getting closer and closer to that one. It really is getting closer, but still it's a shift of 2. So here is your k of x here. Does that make sense, folks? Anybody? Any questions? Anyone saying, wait, I don't understand how you did that? Okay, everybody got it? Well, there is also, in your book, you can see how they did it. It's not on the PowerPoint, but there's also a checkpoint. So you can do the various checkpoint problems there. So, that's at the bottom of page 70. Now let's go back. If there's no questions here, first thing I do before I leave, I'm going to go back to my black lines here so I won't forget that. Okay. Oh, here comes Weston coming in. So let me get him here. There we go. Okay, turning out to be a pretty good attending class today. I'm up to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. This says I've got, where is my pen? It says I've got 20, and that's because we're still missing, I believe, Jacaria. She had to sound like get kids off to school or something like that. It sounded hectic in the background. All right, Weston, you just came in. We just finished example 3 on page 70, chapter 1, functions and their graphs, section 1.7, transformations of functions. We were doing example 3, reflections and shifts of a square root function, and that's what this mess on the board is. You can see it in the book and hear them talk about it. Okay, so we're going back to the PowerPoint now, and we just lost somebody else. I'm almost guessing that may have been Weston. He may not have been able to get everything.
No, sir, I'm here.
Oh, he's there. So somebody else had to leave, but Oh, yeah, I see your name now. It's right there. Is that you catching the ball, or is that you defending the ball? Never mind, I'm just kidding. That's you catching it, huh? 88?
Yeah, that's a little old picture.
Oh, it's a nice picture, though. Okay. So let's go to current slide. And there we go. We finished that slide, and we're going to non-rigid transformations. Okay, now what do we mean by that? Horizontal shifts, vertical shifts, reflections are all rigid transformation because the basic shape doesn't change. It just moves around or turns over, but the shape stays the same. Okay? Those transformations change only in the position of the graph on the coordinate plane. Non-rigid transformations are those that cause a distortion, a change of the shape in the original graph. And I'll give you the changes that we have. They can be, let's take horizontal first. They can be stretched horizontally or compressed. We call it shrunk horizontally. They can be stretched vertically or shrunk vertically. So say if you had a parabola going like this and you stretched it vertically, it would go up more sharply. Okay? If you stretched it horizontally, it would flatten out a lot. Okay? So those are your non-rigid transformations because they do cause a distortion in the shape of the original graph. Okay? For instance, a non-rigid transformation of the graph of y is equal to f of x is represented by this. G of x is c times your f of x. What is that doing? You are multiplying the y values. F of x, remember, is y. You're multiplying the y values by c. Now, if c is a large number, meaning greater than 1, that's a vertical stretch because now all your y's are being stretched upward. Okay? But it's a vertical shrink when c is between 0 and 1 because now you're multiplying by a smaller number, so all your y values are getting reduced. Okay? Now, notice they say between 0 and 1. 1 is the original thing. That's just f of x, g of x equal f of x. So we don't mess with 1. We don't mess with 0 because that wipes out everything. And we don't mess with negative numbers because we already dealt with that. Those are reflections. Okay? So you can have reflections and stretches or shrinks, but treat them separately. So always treat the c as if it's positive. And if it's negative, you just reflect. Another non-rigid transformation of y is equal to f of x is represented by h of x is equal to f of cx. Now you're multiplying the x by a number. Now remember, everything to do with x's is backwards. So if the c is greater than 1, it's a shrink. Okay? If it's less than 1, a small c, it's a stretch, horizontal stretch. Just have to remember, everything dealing with x's are backwards. Dealing with y's, they go like you would expect. Okay? That's a lot of blah, blah, blah. Let's actually do one. This is example 4, about the upper part of the middle part of page 71. Now, compare the graph of each of these functions with the graph of f of x equal absolute value of x. So let's draw that first. So here's going to be my y-axis, supposedly straight and vertical. It is neither. And here's going to be my x-axis, supposedly straight and horizontal. It is neither. And let's tick off a few points. 1, 2, 3, 4, 5, 6, 7, 8. Negative. 1, 2, 3, 4, 5, 6, 7, 8. Positive. 1, 2, 3, 4, 5, 6, 7, 8, 9. Look at that. Okay. Now, absolute value of x. When x equals 0, y is equal to 0. Starts at the origin. Okay. When x is equal to 1, the absolute value of 1 is 1. That goes right there. When x equals minus 1, the absolute value of minus 1 is also 1. So that goes up here. Okay? 2 will be 2. Negative 2 would be 2. 3 would be 3. Negative 3 would be 3. So you can see what it is. Now this is not smooth down here. This is pointed. So this is going to be a line, a straight line, if I could draw a straight line, that goes right up through there. And over here is basically your identity function. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 8, blah, 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 and on and on. There is your parent function, f of x equal absolute value of x. Now this time I'm going to try to do some colors here. Can you see these colors? You probably can't. I've got black, I don't know what color that is, a dark red, a little bit lighter red, a sort of an orangey yellow, a bright yellow, a light green, sage green, a blue green, well, I don't know, and then some blues and a lavender or purple. Pick a color. Anybody? You want black? Orange. Okay, we'll try to do this orange. Hopefully you'll be able to see it. Okay, so we're going to do our h of x in orange. If I can get my pen to show up. Here it is. So we'll do h of x in orange. So that sort of looks yellowish to me, but it's the closest orange I could get. What are we doing here? We're stretching, multiplying all of our y values up here, your f of x values. Where is my pen? This orange doesn't show up well on the screen. There we go. It's right here. Taking this, I still can't find it. There it is. Okay. Taking this and multiply it by 3. So 3 times 0, your y value here is 0. 3 times 0 is still 0. 3 times 1 here is going to be 3. 3 times this one, the y value, is going to be 3. Okay? 3 times 2 is going to be 6. That's 4, 5, 6. That would be right here. Get out of there. Okay, now this is this is so hard to see. Oh, here we go. Here we have a 2 here. 2 times 3 is 6. There's 3, 4, 5, 6 right across from that one. Okay, so that's right there. And the next one's a 3 here. Where are you, pen? There you are. Okay, here's a 3. 3 times 3 is 9. That's 3, 4, 5, 6, 7, 8, 9. And here we go, somewhere right around there. And over the minus 3 here is also 3. Remember, the absolute value is 3. If I could only find the pen. Where are you, pen? There we are. Okay, this goes up to 9 also. All right, now if I can connect the dots, okay, this one, the h of x, this isn't going well at all, comes down here and makes a very sharp V. Okay, I don't know. I can remember when I was a boy child, they had these little things that had strings on them. They were little floppy people, had beads for arms and stuff like this, and they had strings on them, and you pulled them up and the arms went up. That's a vertical stretch. You took this function here, the red function here, the f of x, and stretched it vertically, pulling up the arms. The bottom stayed right where it was, you just pulled up the y values. That's a vertical stretch. Okay? The g of x here if I could find it. Oh, what color you want with g of x? Okay, I've got to find my... Okay, here we go. Okay, we still have black, a dark red, light red, a yellow, a sage green, a bright green, a light blue, a middle blue, a dark blue, and a purple. Oh, I can read what it is. This one they say is dark red, that one say is light red, orange, we did orange, yellow, light green, green, light blue, blue, dark blue, and purple. They named the colors for us here. Pick a color. Not red, not orange. Purple. Okay, we'll go with purple. Oops, I don't think I got purple. Okay, yeah, we got purple. So G is going to be purple here. A little bit darker than our lavender before. This time we're taking all of the y values, the f of x, and we're multiplying by 1/3. In other words, a number between 0 and 1. So 1/3 of 0 is still 0. 1/3 of 1 is 1. 1/3 of 1 over here is 1. I mean, it's 1/3, not 1. 1/3. 1/3 of 2 here would be 2/3. That's just right up to here. 1/3 of that 2 is going to be 2/3. That would be right in there somewhere. This one was 3. 1/3 of 3 is 1. Okay? And this one was 3. The y value was 3, and 1/3 of that is 1. Somewhere in there. So you see what's happening here. This is flattened out. Okay? And this one over on this side is similarly flattened out. I can't draw backhanded very well. Okay, something like that. What I think of this is the elephant came and sat on the red thing. And when it did, you had a vertical shrink. You squished it. Okay? So that's your g of x. Does that make sense? All right. No objections. Let's see how they do it. And I can even erase the screen now. I didn't, all this time before, I thought I didn't know I had this toolbar down here because it disappeared. I'm going to erase all our ink and see what they do. So here is the f of x equal absolute value x, that pale line down there. Let me make sure nobody else is coming in. Nope. Okay. And when you do multiply by 3, vertical stretch upward, and it brings up both of the wings upward. Okay. There is your h of x is 3 times the absolute value of x. Basically, you take the 1 here, multiply it by 3, and it goes here. Take the 1 here, multiply it by 3, and it goes right there. And so on. Okay. Let's do the b part, if I could get my thing to... Okay. Similarly, the graph of this, you're multiplying your y value, the absolute value of x, by 1/3, multiplying the f of x by 1/3. So 1/3 of 1 is 1/3. 1/3 of 2 is 2/3. 1/3 of 3 would be 1. So here it is. That's the one the elephant sat on. It's a vertical shrink. Make sense? Just like we did it. Okay, that was example 4, and that is the last slide they show. Okay, following example 4, of course, is a checkpoint. Please do your checkpoints. But there is an example 5 that we'll do on the whiteboard. Okay, so let's go to the whiteboard and clear this. Does anyone need those old drawings any further, any longer? That was example 3 on the previous page. So if no one's saying anything, I'm going to erase them all. And example 5, you can also go to larsonprecalculus.com for an interactive version of this type of an example. Okay, it says here, compare the graph of each function with the graph of f of x is equal to 2 minus x cubed. Okay, now there's your function. F of x is equal to 2 minus x cubed. Now we got problems here, don't we? What's the parent function of this? That would probably be your cubic function. So I'm going to draw that one first. Okay, now I think we're running, well, we're not, we got some time. I think we'll finish the problem, but I'm going to try to hustle on this one because it's got a lot of steps to it. Get out of there. This whiteboard leaves a lot to be desired. Okay, and my abilities to use it are even more to be desired. All right, now I'm going to start with another color, and since y'all speak up so slowly, I'm going to start back with our lavender again. Okay, I'm going to do just the cubic function, x cubed in lavender. It's going to be 0, 0. Oh, let me tick off my points. Let me go back to black and tick off my points here. I forgot to do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In the old days, I had a program, we used a program, not Screencast-O-Matic, but it was the predecessor of Screencast-O-Matic. It was called Tegrity. Boy, what a powerful program that was. Okay, and it had a graph sheet on it. I didn't have to do this on that one. Screencast-O-Matic, the school went to the cheaper model, trying to save money, which I understand. I'm cheap too, but it sure made my life harder because now I have to draw the graphs, and you see how lousy they come out. Okay, let's go back to lavender here. Okay, and x cubed, when x is 1, 1 cubed is 1. When x is negative 1, negative 1 cubed is negative 1. Okay, when x is 2, 2 cubed is 8. That's 1, 2, 3, 4, 5, 6, 7, 8. Just barely got it on there. Okay, so that would be 8. When x is negative 2, negative 2 cubed is negative 8. 1, 2, let's see, let me do it here. 1, 2, 3, 4, 5, 6, 7, 8. Barely got that one on there. Boy, I lucked out today, didn't I? So it's down here somewhere underneath 2. Okay, so this comes up. I'm drawing backhanded again. So it comes up, flattens out here, and then shoots up here. That's your parent function, the cubing function. But we're negating that. So let's pick another color here, say red, and red is going to be minus x cubed. That's going to negate it all. So the negative of 0 is 0. The negative of plus 1 is going to be minus 1. The negative of minus 1 is going to be plus 1. And the negative of plus 8 is going to be minus 8. And the negative of minus 8 is going to be plus 8. So here is the minus x cubed. That's a pretty ugly drawing, but something like that. Now we're going to do, and this may be a little fuzzy, this is going to be sort of a pink here. The 2, if I could find my pen, where are you, pen? Yuck! That took me right out of my screen share. Between Zoom and, okay, here we go. Now, I was looking for my pen. There's my pen. Okay, this thing right here, this is pink now. Boy, that's a bright pink, isn't it? That's minus x cubed plus 2. So this is going to take that red thing and move it up 2. So the 0, 0 goes here. This red here, which was a +1 here goes to +3 here. The -1 here goes up to, so it goes to +1 there. Okay, this one goes off scale, but this one comes up to +7. Okay, so it's going to be right about there. Okay, now, so this is coming down like this, off scale here, flattens out here, and comes down here. Now they started off with this. This is my f of x, is the pink line here. Do you want me to erase these other two so they don't confuse the issue? Yes or no? I think I'll erase them, because otherwise I'm afraid you'll get them confused. I just use those as construction lines so that I could draw my pink line the way I needed to. Okay? I'll leave that dot down there because I'm afraid if I try to change it. Okay, so there's our original function. F of x is equal to 2 minus x cubed. Okay? The A part here says find g of x. Now I need another color for g of x. I think I'll go back to, yeah, should have done F in black because I already had it in black. So let's do g of x in this whatever color that is. Okay, here's our g of x, sort of a dark brown or something like that. G of x is equal to, yes, is it time? Oh my goodness. Can y'all look at the book and finish this? Or we'll pick it up next time. Okay, we won't have much to go. Remind me I don't need to do 1.7 on here anymore. So this will be, I'm going to pick up with the pink line. I'm not going to go back how I got it. So this will be the A part right down there is where we'll begin. Let me erase my former mark on the page here, and let me give you your homework exercises. Okay, basically it's just about anything back here. Any of the odds, 5 or 7, they're both at Calc Chat. 9 is at Calc Chat. 11 or 13 are both at Calc Chat. Any of the odds 15 to 19, they're all at Calc Chat. 15's at Calc View. 21 to 37, they're all at Calc Chat. We'll talk about these more next time. 21's at Calc View. 39 to 45, they're all at Calc Chat. 39's at Calc View. 47 or 49, they're both at Calc Chat. 51 or 50, any of the odds 51 to 55, they're all at Calc Chat. 57 or 59 are at Calc Chat. 61's at Calc Chat. True false 63 or 65's at Calc Chat. And then any of the odds 67 through, I think it goes to 71, they're all at Calc Chat. All right, and we'll pick up and go in a little more detail next time. Any questions before we leave today? Okay, I'm going to stop sharing because I'm sick and tired of sharing. If I can just find my pen here. Okay, there it is. So stop the sharing. And please, folks, have a good, safe weekend. Work on your research papers. Work on that first test. Get going, and we'll see you on Tuesday. Any last thoughts or questions before I let you go? Bye-bye all. Well, I'm trying to end the meeting, but it won't. Take care. See you next time, Tuesday.